All right, chemistry, let's do a little practice at the end of our chapter, chapter 7. It's just a multiple choice question. Be sure to press pause so that you can attempt these before I show you the answer. Let's give it a shot. Which of the following compounds does not contain a polyatomic ion? Sodium carbonate, sodium sulfate, sodium sulfite, remember referring to one fewer oxygens than the 8, or sodium sulfide. Press pause now. Correct answer is D, sodium sulfide. Remember, for a monatomic ion, we replace the ending of sulfur with IED, so sulfide. That's a sodium sulfide. Na2S would be the formula. So the correct formula for ammonium phosphate is, go ahead and press pause now. Remember, my hint is that the charges for an ionic compound have to algebraically sum to 0. So press pause, do some addition, come back. Correct answer is A, because ammonium has a charge of +1. Phosphate has a charge of -3. And so I need 3 ammoniums to balance out the charge of 1 phosphate. Now, if you're not sure what these charges are off the top of your head, that's fine. You don't have to. Use your textbook. Use your notes. Use your review notes. There are tables that have the charges of common polyatomic ions on them for your convenience. When writing a formula for a compound that contains a polyatomic ion, should we write the anions formula first? Use subscripts to show the number of polyatomic ions present? Should we use parentheses if the number of polyatomic ions is greater than 1? Or should we always place the polyatomic ion in parentheses? I'm going to press pause now. We want to use parentheses if the number of polyatomic ions is greater than 1. So if you have 1 phosphate, you don't need to have parentheses. If you have 1 sulfite, you don't need to use parentheses. But if you have 2 nitrates, right, or like in one of the previous problems that we just looked at, if we have 3 ammoniums, we have to put parentheses around that so that that subscript of 3 indicates the entire unit. So the correct name, this one might be a little bit tricky, guys. The correct name for NH CH COO is, go ahead and press pause now. It is ammonium acetate, right? I hope you recognize that NH4 as ammonium, and A, B, C, and D all had ammonium in them, so that was kind of a no-brainer. But the question is what follows? The CH3COO, is that a carbonate? Is it a hydroxide? Is it an acetate? Or is it a nitrate? And as much as I would love it if you were so familiar with these polyatomic ions that you could memorize these and answer these off the top of your head, you don't have to. You're always going to have access to tables that give you these names. Which of the following is the correct formula for iron 3 sulfate? Go ahead and press pause now. Correct answer is C, Fe2SO4 3. Now, this is iron 3 sulfate, meaning this is a type of iron that has a +3 charge. And so if we have 2 iron 3s, which is what option C is telling us, we have 2 iron 3s, that's going to be a total charge of +6. Sulfate has a charge of -2, and if we have 3 of those, we have a charge of -6. And so the algebraic sum of those charges will be 0, which has to be the case for every neutral compound, of which this is. So the molecular compound for acetylene, is C2H2. The molecular formula for benzene is C6H6. The empirical formula for both of them is, press pause now. It's CH, because I can reduce acetylene by 2, right? I can divide both of those subscripts by 2, it's CH. I can divide both of those subscripts in benzene by 6, and it comes out to CH. Remember, the smallest whole number ratio of atoms in that compound. So which of the following shows the percentage composition of H2SO4? So what you're going to have to do is press pause and calculate on a spare piece of paper the percent composition of H2SO4. Please press pause now. Completing the proper calculations, you should find that this substance, H2SO4, is 2.1% hydrogen, 32.7% sulfur, and 65.2% oxygen. Which of the following compounds has the highest percentage of oxygen? And again, you're going to have to press pause and calculate the percent due to oxygen in all 4 of these options and choose the highest number. So please press pause now. H2O is going to have the highest percentage of oxygen. Not necessarily the most oxygen, because carbon dioxide has 2 oxygens, and that sodium carbonate has 3 oxygens. But we're talking about the percent mass compared to the entire sample. But because the only other thing present in water is those 2 teeny tiny hydrogens, it has a larger percent oxygen. So the empirical formula of a compound that is 1.2% hydrogen, 42.7% chlorine, and 56.8% oxygen is, again, you're going to have to press pause and calculate from this percent composition the empirical formula. Remember, go from percent composition to mass composition to molar composition, and then you can find the smallest whole number ratio. Press pause now. Correct answer is C. 1 hydrogen, 1 chlorine, and 3 oxygens. Let's try a short answer. When a new substance is synthesized or is discovered experimentally, the substance is analyzed quantitatively. What information is obtained from this typical analysis, and how is this information used? Well, what we've already done in this chapter is we've taken percent composition, we've assumed a 100-gram sample, we've gotten the mass composition, gone to the molar composition, and then to the smallest whole number ratio. But what is the smallest whole number ratio of elements called? Oh yeah, it's the substance's empirical formula. So the answer here is the percent composition is obtained and used to determine the substance's empirical formula. And that's what you will be doing for this test. An oxide of selenium, right, that means selenium that has some number of oxygens. An oxide of selenium is 28.8% oxygen. Find the empirical formula. Assuming that the empirical formula is also the molecular formula, name that oxide. Uh-oh, we got multiple things here. So please press pause and take those percent compositions. And by the way, there's only 2 elements here, so you know what the percentage of selenium is because you've already been told the percentage of oxygen. So go from percent composition to mass composition to molar composition, then to that smallest whole number ratio, which is the empirical formula. Once you've done that, I'll go ahead and tell you that that is the molecular formula, then give me the name. Press pause now. So you should find that they occur at a 1:2 ratio. 1 mole of selenium for every 2 moles of oxygen. And once we assume that that is the molecule, the actual molecular formula, we would call that, because both of them are non-metals, and so they're covalently bonded, that is the molecular formula. We're going to have to use the prefix system for naming, selenium dioxide. Uh-oh, responses are getting a little bit longer. What is an empirical formula, and how does it differ from a molecular formula? Well, guys, this is one of your big objectives for the entire section, right? When we went over empirical formula. Now I want you to just do it. Explain the relationship. The empirical formula is the smallest whole number ratio of atoms in a chemical formula. The molecular formula is the actual number of atoms in each element in a chemical formula. The 2 formulas differ by some integer factor. Remember, I represented that integer by an x, that variable, that multiplier. What are stock system names based on? Right? The stock system is that system where we use parentheses to identify the charge of the cation, or in some cases, the oxidation number of the first element listed. Because remember, we can use the stock system to name molecules. But please press pause and generate your answer now. The stock system is based on the oxidation number of the cation. Now, before you want to come back and say, well, Mr. Johnson, I thought it was represent the ionic charge. Well, it can do that, but realize an oxidation number is identifying, it's describing the general distribution of electrons. If an ion has a charge, that means that there's been a complete transfer of electrons. So I can describe how the electrons are distributed simply by telling you that that electron is now closer to that cation. Or should I say further away from that cation, which is actually what's going to happen. But yes, they can be used interchangeably for that Roman numeral that's in the parentheses that follows the cation. All right, and that'll do it for our practice. Good luck on this test.